Okay, so we have been learning about rational numbers, how to convert them into decimals and see whether they are terminating, non-terminating and so on. Of course, the reverse also we did. From terminating and non-terminating decimals, we converted them into P by Q form. Okay, there is one more thing that is left. We saw in the number line that between any two numbers, whole numbers or integers, there are infinite number of rational numbers just packed there. We went on magnifying and found new and new and new number inside them. So, it seems there are like between any two natural numbers, any two fractions, any two decimal numbers, there are again infinite number. Suppose you are asked to find few of them. Okay. So, what happens is if I say 2 and 3, I want you to find one rational number between the two. Okay. This is a rational number, this is also a rational number, we know that. If I divide this by 1, this becomes 1, isn't it? All natural numbers are rational number. By converting into fraction also, I have proved that they are rational numbers. Find one number between the two. Finding one number is extremely easy. It lies between the two. You know very well that if I find average of these two numbers, it has to lie between the two. So, if I find average, 2 plus 3 divide by 2, which is 5 by 2, which is 2.5. So, there is a number 2.5 here. 2.5 is a rational number, isn't it? It is a decimal number, so it is rational number, it is a terminating one. It lies between 2 and 3. So, finding one rational number is not tough, but this is not the only answer. Just because you are given a question, find one rational number, you have written 2.4, somebody else would have written 2.5, somebody else would have written 2.4, somebody else would have written 2.3, all are right. Okay. So, your answer is right, that is okay, but this answer is also right, this is also right, but to find one, easiest is to find the average. This is not average, but this is not wrong, but to find one, all you have to do is just find one average of the two numbers, you will get an answer. Suppose you are asked to find one more rational number, okay, then what you can do, find the average between these two, 2 and 2.5, that also is going to lie somewhere here in between the two, in between 2 and 3. So, 2 plus 2.5 by 2, which is 4.5 by 2, which is 2.25. This is also a rational number, a digit, a decimal number terminating, which is lying between 2 and 3. So, I have found one more. Similarly, here also I can find, so if I find between say 2.5 and 3 and divide by 2, this is 5.5 by 2 and that will give me 2.75, which lies somewhere here, 2.75. And I can go on, and again these two numbers I can find one, between these two I can find one, between these two I can find one. This is one method, but it is not very, very a number, something that we can do in one stroke. You do not want to go on and on just for a 1 mark question, you do not want to do so much of thing. One number finding is okay, two numbers okay, do not mind spending a little time. But if suppose you are asked to find say 10 numbers between them or say 50 numbers between them, it is foolish to go take this method of finding. So, there must be some other method, something, there are many methods of course, some of the shortcut methods, one of them I think I can show you. Okay. So, the first thing is what we will do, the same 2 and 3 I will take, and suppose I am to find 5 numbers between the two, 5 numbers, of course orally you can do, there are already 10 numbers, 2.1, 2.2, 2.3 and all that, because the numbers are very simple, but the method of course we can learn so that we can use it for any type, we can use it for any type of fraction also. Okay. So, I have converted 2 and 2 in terms of fraction and I have to find 5 numbers. Okay. So, since I have to find 5 numbers, the question says please find 5 numbers, 5 rational numbers between 2 and 3, I take this 5, add 1 to that and make it 6. After that, these two are the fractions, I have converted them into fraction by dividing by 1. I multiply numerator, denominator by 6. So, this will give me 6 2s are 12, 6 1s are 6, here 3 6 are 18, 6. This number and this number is the same thing, isn't it? They are equivalent fractions as they call it, so the values are same. So, instead of 2 by 1, I can surely write 12 by 6, nobody can stop me. Similarly, 3 by 1 is same as 18 by 6. These two are also rational numbers. How many rational numbers you can just by looking at it find? Something here, 13 by 6, another one 14 by 6, then 15 by 6, 16 by 6 and 17 by 6. And how many you wanted? 5, you got those 5. They lie between 2 and 3, 13 by 6, 14 by 6, 15 by 6, 16 by 6 and 17 by 6. So, it is one of the easiest method of finding. How many you want, add 1 to that, you get the next number, the given fraction you should be multiplying, provided the denominators are same. Okay, let us do one more example. Say let us say 2 by 3 and say 4 by 5. Now the denominators are not same. Okay, and I am supposed to find says same way 5 numbers. So I will do 5 plus 1 6. I know I have to multiply by 6, but here I cannot multiply by 6. Here the denominators were same. Here they are not same, so I just cannot keep on multiplying by 6. What I should do, I should make the denominator same, and for that we find the LCM. So this becomes 15, 5 2s are 10, and what is this? 3 5s are 3, 12, isn't it? Yeah, 4 3s are 12. Okay, now the two fractions are 10 by 15 and 12 by 15. These two are the fractions. You have to find 5 numbers between them. By looking at it, I can find one very easily, that is 11 by 15, because 10 by 15, then there is 11 by 15 which I can find. But what about other numbers? There are infinite numbers between them. Of course, not all of us will find the same infinite number, but if you follow this method, probably all of you will get the same answer. Not that it is wrong. You can try any way you feel like. There's another easy way is you multiply both of them by 10. Okay, 10 10. So you will get 100 by 150. 120 by 150. So between 100 and 120, you have 20 numbers. You can choose any 5 of your choice. But if you want exactly 5 numbers, this is the method you have to use. So 6 I multiply throughout by 6. This and this, because they have the same denominator. So if I multiply by 6, what do I get here? 10, 60, 90, isn't it? And here is 72. Here also it is 90. Correct? So I have got 60 by 90, which is the same as 10 by 15, 72 by 90, multiplying by 6. 6, 15, 6 are 90 and 15, 6 are 90. Numerator 6 into 12, 72, and 6 into 10, 60. So these two are the same numbers. This number is nothing but this number is nothing but this. So instead of finding between these two and in one look I am able to see only 11 by 15, others are hiding somewhere, I am not able to see. So I am magnifying. I am just making the denominator bigger correspondingly. So multiplying by 6 throughout. Now look at this, a huge space is here. How many numbers you can find? 61, 62, 63, 64, so on up to 71. So there are almost 11 numbers lying there. Okay, you choose 5 of your choice. You can write all the 11, take any 5. You will be writing one 5, your friend will be writing other 5, that is okay. Since there are infinite numbers, it doesn't mean that you and your friend should have the same answer. You can have your own choice. So between 60 by 90 and 72 by 90, the numbers you are getting is 61 by 90, then you have 62 by 90, and so on up to 71 by 90. Choose any 5 of your choice and write the answer. Okay. So what have we learned here? If the denominators are same with the numerator, you have to find the number of rational numbers. The question says 5 numbers, 6 numbers, 10 numbers. Find 10 rational numbers, find 11 rational numbers. So if the question says find 10 rational numbers, you have 10 plus 1, 11. Multiply everything by 11, get the answer, and you will always find many numbers lying in between. Those will be the 11 numbers which are lying in between. This is when the denominators are same. If they are not same, we will make them same. That's not like we don't think that is difficult. We know how to find LCM and make them as equivalent fraction. And once the equivalent fractions are got, the same method, I want 5, I multiply by 6, I get a 2 set of fractions. There are so many things inside them, between them. I can choose whatever I feel like and write the answer. So this is how rational numbers are found. Rational numbers between two rational numbers are found. Later on when we will be doing irrational numbers, we will also learn how to find irrational numbers between them, but that is a later on topic. Here it is rational number between two rational numbers. So this can be done very easily, simple method. There are other methods also, but this is one of those easy method for you to use and find. Please remember the number of rational numbers you need to find, just add 1 to that, make another next number, multiply both the numerator and denominator of both the numbers, and then continue.